In the previous video of this series, we had discussed about object-oriented programming. In this video, we are going to discuss about principles of object-oriented programming. Java is an object-oriented programming language. Therefore, we should know the principles of OOP before we start coding. So the principles of object-oriented programming are encapsulation, polymorphism, abstraction, and inheritance. So in this video, we are going to discuss each of these concepts in great detail and understand how does this concept help us to program better. So we will begin our video by understanding what is abstraction. So the first thing that should come to your mind when you hear abstraction is hiding unwanted details. We know that car is a very complicated system consisting of millions of parts like engine, transmission, brakes, etc. But you can still operate a car without knowing the finer details like how does the engine, transmission or the brakes of the car work. So this is what we call as abstraction. So abstraction is nothing but hiding unnecessary details from the user. So we will understand why is this useful. This makes your code or software easy to use. This will in turn make it highly usable. So every video that we will shoot from today will have something called as bonus round. So it contains question and answers that are likely to be helpful for your interview. Along with it, we are also planning to provide some programming examples related to that concept. So how to what you can say approach this is I want you to pause the video and try the questions for yourself first. Once you get the answers, you have to comment your answer. After that, you have to compare the solution to the solution that we provide. You all to practice well with the bonus round. And with that being said, we will go to the second principle of OOP, that is encapsulation. Encapsulation is nothing but binding of the data with the code. So what do you mean by this? Suppose we have data here. As we know, object-oriented programming is mainly centric about data, like it gives so much importance to data. Okay, so you have data here and you will bind the code which is going to act upon the data. So what do you mean by this? You have a data here and you're going to tell what type of operations that can be performed and who is going to perform the operations on the data. Operations in the sense, for example, we have how to modify or change the data. So you're going to specify what kind of modification or the changes a code can make on the data, and you're specifically telling which part of the code can make the changes to the data. So this is what we call as encapsulation, that is binding of the data to corresponding code. So that is what it is written here. Mechanism to bind the code and the data and prevents outside interference and misuse. It serves as a protective wrapper around the code and the data. So it serves as a protective wrapper. Suppose there is a piece of code that is outside this wrapper and it is trying to access and modify the piece of data here. So with encapsulation, this won't be possible because we have binded the data and the code. So only modifications to the data can be achieved only through the code that is binded with the data. We have just learned that encapsulation is nothing but a wrapper around the code and the data, right? In Java, this is done with something called as class. So class is nothing but it defines structure and behavior of object. So class consists of two things, that is the data and the code, right? The data part of the class is called as the member variable, and the code part of the class is called as member methods. So data part of the class defines the structure of the class, and the code part defines the behavior of the class. Okay, these two together forms the member of the class. So we will try to understand this with an example. Suppose that if you want to build your home, what will you do? You will first go to an engineer, right? Engineer will discuss with you and provide you a blueprint. Correct? The blueprint will define how many rooms you will have and what is the functionality of each room. Correct? Once you obtain the blueprint, you are going to construct the home. Once the blueprint is obtained, it is sent for construction. Once the construction is completed, you will get your home. Right? This home will have all the structural and the behavioral property that is defined in blueprint, right? This is what we call as object. So object is nothing but physical existence of class. You have a blueprint here. So once the blueprint is built in real world, that is what we form, that is what we call as object. So blueprint here is nothing but class. So it defines the structural and behavioral property of object. I hope this example is clear. We will dig deeper into what is class and programming with it in later videos. But one more thing that you have to know is the members of a class, member of the class can either be public or private. There are few more other things that you have to know, but for time being, let us say they belong to either of the two, the public and the private types. There are certain instances where you want your members of the class to interact with the outside world. If that is the case, you declare them as public. Let me recall, if you declare your member functions or member variables as public, it will be visible to other code or the data that you define outside the wrapper. That is if you declare it as public. If you declare the member function or the variable as private, then it will be only visible within the class or the wrapper. So this is encapsulation. So why is this helpful? It will provide you security mechanisms. You are showing only what you want to show. So first thing is security, and this also helps in abstraction. So that's it. So now we are going to discuss about the third object oriented principle, that is inheritance. So let us go through the definition here. Inheritance is a mechanism through which object acquires the property of another object. So for time being, let us forget Java and in simple terms, let us know what is inheritance. So in common English. So inheritance is something where you have a parent and you have a child, right? So child acquires the property of the parent, right? This is what we commonly call as inheritance. Similarly, in programming, this works as quite similar to that of the real life. You have a class A and you have a child class of class A. Let us say it's class B. Okay, class A is the parent class, also called as superclass. Class B, which is the child of class A, is also called as subclass or child class of class A. As in real life, class B acquires all the properties of class A. We know that class contains data and the code, as we have learned in encapsulation, right? So class B will have the access or inherits all the properties such as its data and the code of class A. But the inverse is not true. That is, class B will not give any features to that of class A, or property will not be given to class A. So this is what we call as inheritance. We will understand this with an example. Suppose you are building a game where you have to make use of so many vehicles. So each time a new vehicle is to be created, you have to write so many code for defining its shape, how it is going to behave when you're giving accelerator and brake and various other inputs, right? Each time you have to provide the code for defining all this behavior. And whenever a new vehicle is to be created, you have to again write all this code again and again and again. So this is quite repetitive and boring, right? That is why we use something called as inheritance. In inheritance, you will define a vehicle class first, and you define all the properties here, like how it is going to accelerate, how it is going to brake. All this stuff will be defined in a class named vehicle, and you are going to extend, or the child classes will be created of the vehicle class, like bike, car, truck, then say SUV. So vehicle class will be created, and the child class of this vehicle class will be all those stuff. So all the general properties that a vehicle will have will be defined in the vehicle class, and all the specific things that a bike has will be defined within this class. All the specific things that is defined within a car will be coded here, and all the specific things related to truck will be defined within the truck class, and all the specific things that is specified for SUV will be specified here. Okay, so that you don't have to repeat the code every time for bike, car as well as truck. So this is why you use inheritance. It prevents you to writing code again and again and again, and it also provides you hierarchical classification. That means you have vehicle here and bike. You can also specify within this as quad, bike, etc. Now we are going to discuss the last object-oriented principle, that is polymorphism. It is derived from a Greek word. So we will see. So it has two words in it, poly and morphism. In that, poly means many and morphism means forms. So one key feature that you have to remember in polymorphism is one interface and multiple methods. So what does that mean? We will understand with an example. Suppose there is a superclass. So I have explained this in inheritance. You can check there. This is a general class named animal. Suppose that it has a member function or a member method named as eat. So animal is a general class, right? So we will say animal eats. We don't know which animal it is. Suppose there are two child classes, namely a dog and a cat, right? So you have your animal class here. This is the parent class, and you have cat and dog as their child class, because animal class is more general class. Cat and a dog class are more specific classes of animals, right? So when I create an object of animal class and call the eat method that is being defined within animal class, so this will print me animal in the output, right? Animal eats will be the output. But As you can see, I have the same method written in both the child classes here in the dog class as well as the cat class. I have the same method named as eat. So now I have assigned an object of animal class to this variable. As you can see here, now I am assigning an object of dog variable to that of animal and I am calling animal.eat. So what does this do? So Java compiler is smart enough to understand that the animal.eat, the animal here is a dog. Okay. So it is smart enough to understand that animal that you are mentioning here is that of dog. So it will go to this definition here, this method definition, and prints dog eats. Same happens here. When you call this method, that is animal.cat, our Java compiler is smart enough to understand that cat is being referred as an animal here. So cat eats will be printed. So this is what we call as polymorphism. This is what we call as polymorphism. So the behavior is getting adjusted to the situation. So this is very important and you should know. As you can see in the example, when animal is being referred to as a dog, so that method is being executed. When cat is being referred as an animal, the cat's method eat is being executed. So Java is smart enough to understand this. This is what we call as polymorphism, adjusting to the given situation. This is very, very important. Now we will begin with the interview questions. So before we begin, let me remind you the rules. I want you to pause the video for a moment after the question is displayed and take your time to answer in the comment section. Then you can view the solutions so that I will know like what is the situation. So the first question is Java strictly object oriented language? So go on, answer the question. So the answer to this question is no. So you will ask why? Because in Java there is something called as primitive data types. This has not been taught yet, but you should know primitive data types. Example for this are int, float, etc. Okay, so these are not objects. That is why Java is not strictly object oriented language, because it supports primitive data types like int, float, etc. So the second question is, which principle does inheritance support? The answer to this question is something called as dry principle. In software engineering, there are a set of guidelines or principles that if followed can improve your code. Like it is like standard principles. So there is something called as dry principle, that is, do not repeat yourself. So as I told in inheritance, you will have a general class and a subclass, right? This can be more than one subclasses, and you are going to inherit the features from general class to the subclasses. So what you are doing is you're trying to not to write the code again and again. So this follows what we call as dry principle, that is, do not repeat yourself. So that is all for this video, guys. We will be undergoing programming sessions in the upcoming videos. For time being, you should know the concepts before you start coding. So that's all for this video. Thank you.